Welcome back, friends, and this is the third video on sets. So we've looked at a lot, not so much though, but we've looked at members of sets, we've looked at how sets are represented, and in this video we'll move on to what is known as equality of sets. Equality of sets. So two sets are said to be equal if and only if they contain the same elements. Now, I haven't said same number of elements, but I've said same elements. For example, we have set A, which has the elements 5, 7, and 12. And we have set B, which has the elements 12, 11, and 7. Then we have set C, which has A, B, and F. And we have set D, which is equal to 7, 12, and 5. So when you talk of equality of sets, let me just repeat what I said. When we talk of equality of sets, we are talking about two sets that have the exact same elements. Okay, so two sets are said to be equal if they have the exact same elements. Then those two sets are equal. So when you look at set A has the elements 5, 7, and 12. Set B has the elements 12, 11, and 7. Set C has the elements A, B, and F. And set D has the elements 7, 12, and 5. So which two sets have the same elements, or which two sets are equal? Is A equal to B? Well, there's a 12 there, there's a 12 there. There's 11 here, there's no 11 here. There's 7 here, there's 7 here. So these two sets have two elements that are the same, but they are not exactly the same. What of this and this? Well, this one has letters, this one has numbers, so this one is not equal to any of these. What of set B and set D? They both have 7, they both have 12, but they don't have 11 or 5 on both sides. So these two are not equal. But when you look at A and D, these two have the exact same elements, and these elements are in a different order, but they are the exact same elements. So it doesn't matter what order they've been put in, but as long as the elements in those two sets are the same, exactly the same, then those two sets are equal. So set A is equal to set D. All right? Do you understand? Or should I give you another example? So let's look at another example of sets that can be equal. We've got set A, which is equal to A, D, G. We've got set Z, which is equal to 1, 4, B. We've got set Y, which is equal to D, A, G. And we've got set T, which is equal to 4, 1, B. So do you see any equal sets amongst these four sets that I have given you? Do you see any equal sets? Well, which sets have the exact same elements? Well, set A has the exact same elements as set Y, and set Z has the exact same elements as set T. Do you see that? There's an A, there's an A, there's a D, there's a D, and there's a G, there's a G. So these two sets are equal. So you've got set A being equal to set Y, and you've got Z and T, 1, 1, 4, 4, B, B. So set Z is equal to set T. I hope you have gotten the concept on equality of sets. So this is quite straightforward. Just look at the elements in those sets and try to see if they are the same. Okay, we can move on to the next part of this video. The next part that we're going to look at is what are known as subsets. So here we've got a diagram which is showing a subset. So when we talk of a subset, rather when we define a set, if we take pieces of that set and we form another set, we have what is known as a subset. So a subset is simply a set in a set. So as you can see from the subset that we have there, we've got set B, which has the elements 1, 2, 3, 4, and 5. And then we have another set there, which is set A. So set A is a subset of set B, and set A is comprised of 1, 2, 3. So it has the elements 1, 2, and 3. So the elements that are in set A are also in set B. But set B has more elements than those which are in set A. So set A is a set within set B. So set A is a subset. Okay. So let's look at the same example that we have there. We've got set B. Set B is equal to 1, 2, 3, 4, and 5. And subset A is equal to 1, 2, and 3. So if I was to ask you to say, is set C a subset of set B? So look at set C. Set C has 1, 5, and 3. So is set C a subset of set A? Is set C a subset of set A? Well, yes. Set C is a subset of set C is a subset of set B. So just as we had seen when we were looking at member of and not a member of, subset also has a symbol. So the symbol for subset is a C, but not an ordinary C, a C that is kind of long in that way. So if we were to say set A is a subset of set B, if we are to mathematically say that or write that down, we would write A is a subset of B. Okay? And if we were to say C is a subset of B, we would write it in that way. So I want you to pause the video and try practicing the subset symbol. Write the subset symbol on a piece of paper 3-4 times and practice and try to see if you can get it right. So similarly, we also have a symbol which represents not a subset. So the symbol for not a subset is simply, let me write this down, not a subset. Symbol for not a subset is simply this same C that has been cancelled. So if I was to include another set, set D, and set D is equal to 7, 1, 2. Is set D a subset of set B? Well, 1 is there, 2 is there, but 7 is not there. So set D is not a subset of set B. So to write this statement down mathematically, we would write it as D like that, B. And this simply means D is not a subset of B. Okay? And that is how we work around subsets. That's how we work around subsets. So I think for this video we can end here, and we will look at more set notation in the next video. Thank you very much, and I can't wait to hear from you. If you are If you have any questions, if you have any queries, feel free to talk to us, to ask us, and we are more than willing to offer help where we can. So this has been great, and see you in the next video.